So now we are going to see the most interesting part, that how these spheres are arranged in a 3-dimension. Remember, if you just mark my words in the first dimension and the second dimension, I was again and again mentioning that the rows, okay, first row was placed, on top of that the second row was placed. But now when you're dealing with the third 3-dimension, remember, instead of using the term as rows, we will be using the word as layers. That is, means what? If I consider this sheet as your consider, here is your atoms, consider that here all you are having your atoms. So this constitutes your first layer. Okay, this is overall is a first layer. Assume that on top of it you are having, if I consider this one as my spheres like this, they have been closely arranged. Okay, this is all their layers. If you just continue it, just continue in this way. So like this will be your layers. So this overall part will be considered as that what? A layer. Overall thing is a layer. But in the first two cases, in the dimensions, we were just assuming just a single row. This is one row we were taking, and on top of that we were placing another row. That was the thing. Okay, like this we were doing it. So this was in the first cases. But now what you are going to see, we are going to see an overall placing of the layers itself. So here when you are doing with that of the 3 dimensions, you have to remember that we are getting the 2 possibilities. So let me write it in a close packing in close packing in 3 dimensions. So when you are taking the first case, so in the first case we are seeing that when you are placing the second layer, over the first layer, okay, over the first layer, here the second layer whatever you are placing is a square close pack layers. Square close pack layers. That is, if I consider how will be a square close pack layers, if I consider this is your atoms, for example, okay, in a square close pack what happens, the second row will be just on the top of the first row, alva. So this will be your square close pack layers. So now what I am doing, I am taking such a overall layer, not just a single row. Instead of taking, I am taking this one as a whole layer and I am placing it on the first layer. So when you are placing it on the first layer, what you will be getting, so if the first layer is of A type, the second layer will be also of A type. So you are getting as A type arrangement. So when you are placing the second layer of the close pack layer over the first layer, there will be no much changes. We will be getting an arrangement of A type arrangement. When you are coming for the second part, the second is very much important, because here we are placing the second layer. We are placing the second layer of hexagonal close pack layers. We are placing the second layer of hexagonal close pack layers over the first one. That is how we are going to see. If this is your part, we are taking in this way. That is in the depressions of the first. You can just see over here. I am taking the depressions of the first in like this. So this is will be a hexagonal close pack layer. So now I am placing the overall this hexagonal close pack layers over that of your first layer in order to cover the voids. Here we are using the term as voids. Very much important. So what do you mean by this voids? Let us first understand. So voids means nothing. It is an empty space which will be obtained when you are placing the one layer over the above layer. Okay. So a second layer of hexagonal close pack layers is placed above the first layer such that to cover the voids of the first layer. So there are 2 important voids. One is called as that of your tetrahedral void and another is called as that of your octahedral void. Very much important. I'm going to give you the demonstration. Just have a close observation over here. So a tetrahedral void means what? The empty space obtained with respect to the four spheres. The empty space obtained when you are placing the four spheres. That is, let us consider this one is your first sphere, this one is your second sphere, this one is your third sphere. Able to see? So what is happening over here? There is a space, because afterwards I can't able to show it. Even though I am placing my fourth layer on top of it, what happens to that space? It remains as such. That empty space at the bottom remains as such, alva. So this is just placing about this layer, three layers. So what happens in between? That is here, there is a space. So that empty space which has been obtained when you are placing the four spheres, that empty space will be called as that of your tetrahedral voids. So this is obtained when you are placing a second layer of hexagonal close packed layers over the first layer in order to cover the voids of the first layer. So when you are doing that one, first we are getting a one more void which is called as that of your tetrahedral void when you are obtained with respect to when you are arranging the spheres taking your four atoms. The second most important is that of your octahedral. Octahedral means what? We know that it is with respect to the six spheres. So let us see that how it would be now. So if I consider this is my first sphere, here is your second sphere, yes, here is your third sphere, here is your fourth sphere. Okay, remember I am doing for my octahedral. So here is my one more sphere, here is my one more sphere. So you can easily we can notice it. So this is the space what you are obtaining. So this is called as what? As an octahedral void. Why it is called as an octahedral void? Because the empty space is obtained with respect to the six spheres over here. So this is called as that of your octahedral void. When such a void is obtained with respect to the four spheres which I have demonstrated earlier, that will be called as a tetrahedral void. And this is obtained when you are placing the second layer of your hexagonal close pack with respect to cover the voids of the first layer. If I consider the arrangement of the first layer as of A type, the second layer will be of B type. So this type will be called as that of your AB type arrangement when you are obtaining the second layer of your hexagonal close pack layer falling on that of the voids of the first layer. So this is the way what we are doing when you are placing these spheres with respect to the three dimensions. So when you are placing the second layer of your square close pack layer of the first layer, it will be of AA type arrangement itself in three dimensions. Remember, when you are placing a second layer of hexagonal close pack layers to cover the voids of the first layer, okay, to cover the voids of the first layer, we are getting two types of an extra voids over here, which is called as that of a tetrahedral and an octahedral voids. So tetrahedral means those empty space which is obtained, which is covered with respect to that of your four spheres. Whereas an octahedral void means what? The empty space which is covered by the six spheres is called as that of your octahedral void. So this is an example of your octahedral void. In the notes I have given you this structure. Let me write it once again for your clear understanding. Okay, if I consider this one as my spheres, okay, like this. Okay, 3, 3, 6. Okay, like this. Okay, so now what I am doing, I am just placing in the depressions, the second layer of your, like this, we space in like this. Okay, this is your two dimensions. We continue so that it would be easy for your understanding. Okay. Now let me see over here. So now if I am placing a one more layer on top of here, see here what is happening, a tetrahedral void is obtained. I am just covering the first layer. If I consider this one as my first layer, what I have in the pen part I have written, this will be a first layer. Now I am placing the second layer of my what? Hexagonal close pack layers to cover the void. You can just see this is an empty space. I am just covering it with respect to a void. alva, fourth layer, that is 4 atoms. If I'm going to continue it, how you're going to get, see, like this, yes, like this, like this, like this, like this. So on this depressions, if I'm placing now, once again, please don't get confused, because that is the reason I'm writing in pencil, so that you can get a clear image of what we are doing. Now from these structures we are going to see of your tetrahedral and that of your octahedral. Yeah. So when you're writing in this way, now we are going to see, yes, see, if I consider now, so this is your one part, this is your another part, this is your another part, this is your another part. Able to see? Yes, like this, and like this. Able to see? So here we are getting a void. So 1, 2, 3, 4, 5, 6. So this void is called as what? As an octahedral void. Octahedral void. If I consider this part, which one? See, this one. One sphere. Okay. This is the second sphere. This is the third sphere. And this is my fourth sphere. So here we can observe a void which will be called as that of your tetrahedral void. So if I am just writing its mere representation, how can I write? As I have shown in my diagrams. So this will be for your tetrahedral void. So I am placing my one more layer in order to cover this void. So here I am placing. Alva. So this void is called as that of your tetrahedral. If I am writing for my octahedral, in this way. Over here like this, sorry. Like this. So in between you just draw one more. Like this, okay. So here you have to draw one more in this way. And here you just draw and another one over like this. So here we are obtaining a one more void, so which is called as that of your octahedral void with respect to the 6 spheres. 1, 2, 3, 4, 5, 6. When you're coming, you're getting a one more void. But when you're coming with respect to just 4 spheres, it is called as that of your tetrahedral void, as I have shown in my earlier case. So this will be that of your tetrahedral voids. Okay, so like this, and you're covering the 4th part over here. So even in between you have placed, there is a space in between. You can just see my nib going inside. So that will be your called as tetrahedral void. Coming with respect to that of your octahedral voids, it will be similar to in this way. Like this, and over here as a like this. So this is called as that of your octahedral void. So this was with respect to the close packing in 3 dimension. Now next also we are going to see that what happens if we are going to place now one more sphere in this void, whether the arrangement remains the same or whether it changes. So that will be seen in my next video.